For this video, we're going to work on our apprenticeship exercise, and more specifically, the handy array library. So this is going to be like the theme for like the whole series of exercise. We're going to try to build a little library of functions that allow us to handily manipulate arrays of int. And as usual, we're using int arrays because they are like easy, and it's one of the primitive data type in C, right? But everything that we do here with int arrays, you can substitute any data type to your array and modify the function accordingly, which is actually a good exercise if you need a little bit more practice, and end up with a handy array library for example, arrays of doubles or array of float or arrays of chars and so on and so forth. Okay, so first thing I should say, bonus bragging point to whoever can track down where the name HAL come from, okay, and what it means. But jokes apart, so we're going to get started by setting up our project, okay? The structure that we are going to adopt here, we're going to follow the same multi-file structure that we're going to try to consistently follow throughout the semester. So the name of my my quote-unquote library, it's not really a library, right, is HAL. So I'm going to have a header file, hal.h, hal.c, okay? The header file is going to be included from the C file, okay? And I'm going to have, so usually I have a tools, so I have a tools.h, tools.c, right? Well, instead of just naming them tools, I'm naming them with the name of the library here, hal.h, hal.c, but it's the same goal. Those two files are there to contain actually the header and the definition of all the functions that we want to potentially reuse in a bunch of different projects and exchange with our programmer, okay? And then usually we have our main.c, okay? And we're going to have a test.c as well. So the role of the test.c is going to contain a main function. It's going to contain a main function, and inside that main function, we are going to put a bunch of code that actually calls onto the functions from hal.c and use them in specific scenarios that we are going to use to make sure that they are working as expected, okay? So this is where we are going to implement our test. And some of them are going to be automated in the sense that we're going to call the function from hal.c with a certain specific parameter, and then we're going to double check automatically with the if statement that the return value is actually what we expected, and if it's not, then we display an error on the screen. If it is, then we don't display anything, okay? For some other tests, the tests are going to be a little less automated. We're just going to do something, display the result on the screen, and let the programmer check for themselves, if the output is actually what they expected or not. Optionally, we are going to have a main.c. I say optionally because in the case of this exercise, we don't have really much that we can do in the main.c. We could do everything in the test.c, but the idea of the main.c is also to provide an alternative main method, and this one would be where we have, so right now we are going to have nothing to start off with, but this is where we are going to have any part of the code that is interacting with the user. For example, if we wanted to do like we did in the previous module, have a little menu allowing to call all of the different functions from the HAL library, right? Then that's where we would do it. So right now, we're going to ignore a little bit main.c for now. And by the way, remember that having two files like that provide a main function, this is not exactly okay to compile them together. Okay, and by not exactly, I mean not at all. So that means that when we compile our program, like for this first video, I'm going to compile all of this, including the test.c, but leaving alone main.c. Actually, I might not even create it for the first video, okay? The idea being that you should always compile your project to generate an executable with a bunch of files if you want, if you have multiple files, but only one of them should contain a main. So this is either we compile this, or we compile, for example, this here, but we cannot compile main.c and test.c together to form one executable because both of them are saying contradictory things. They are saying, hey, this is where execution starts, and they provide a main method for that. Okay, so now that we have a basic idea of the the general picture here, let's jump into the code. So I'm going to make a folder for this HAL library. So I'm using the mkdir make directory command. Okay. Then I'm going to use cd change directory to jump into that newly created directory. So you can see here that my path has been modified. So I am now inside my home directory, COP5227, and then HAL. Okay, and inside of this directory, there's nothing for now. So I use the ls command list to see what's in my my folder here. There's nothing for now. And now what I'm going to do is I'm going to create a few files. So I'm going to close that old main.c here, but I'm going to cut and paste the content because it's going to be very similar, right? I'm going to close that old main.c here, and I'm going to say, okay, let's open an editor, and I'm going to have hal.h, hal.c, and then we said test plural, probably test.c. And I'm going to put an ampersand at the end of my command line, meaning all of this needs to run in the background. So hal.h, hal.c, test.c, and I'm going to paste what I had in my old main from a previous exercise, right? I'm going to paste it in test.c because this is where I'm going to have my main function. So main function is done. I'm going to say instead tests are completed. And I'm going to start by displaying when I start this thing here, running test on HAL functions. There we go. All right. So we have something that we can already actually compile, except that hal.c, of course, is empty, hal.h is empty. By the way, if I want to be able to use the function defined in my sudo library, I'd better include hal.h. And watch out, I'm using double quotes here. I'm not using angular brackets, okay? So you should know by now why, but if you don't remember, post on the forum, come to see us during the office hours, okay? So I'm including hal.h, I'm going to save this, and now I'm going to GCC. So I want to compile hal.c, which is empty right now. I want to compile test.c, and I want this to give me our directory. So apparently gedit is smarter than I gave it credit for. It didn't save hal.c because it was empty. So here we are. We're going to put a blank line in both of these. Going back here, and we are going to try again to compile. It's compiling just fine. What happened when we run it? Running tests on HAL function, tests are completed. There we go. All right, so we have our basic framework. The next thing we are going to do in this video, we are going to just go one little step further, and we're going to get two of our functions implemented. And these are going to be the very basic function that we're going to reuse all the time. These are going to be a function that allows us to display the content of an array, and a function that allows us to read from the user the content of an array. So because we are restricting ourselves to arrays of int, we are going to actually prefix all of our functions by int array underscore display, for example, and then int array underscore scan. And I'm going to write the prototype here. So I'm not inventing the prototype, I'm following the instruction of the exercise. Okay, so these functions return nothing, and then they are going to take as a parameter an array of int as well as its size. An array of int here as well as its size. One thing I recommend you do is every time you are deciding, that one of your function is going to take an array as parameter, make sure that you ask yourself whether you want the function to be able to modify the element inside the array or not. If the answer is no, for example, to display the content of the array, do I need to be able to mess around and modify what's inside the array data? No, clearly not. I should not have permission to do that. So principle of least privilege, do not give that power to your function if it doesn't need it to do its job. So by using the const keyword here, I'm saying that data, the parameter data, is an array of element of type const int. So the elements themselves are constant, they should not be modified. For scan, well, no, for scan, I definitely need to be able to modify the content of the array because I want to read data from the user and I want to store it inside the slots for my array, right? So I need to be able to modify those slots. So I have here two prototypes for the first two functions that I need to write, and then I'm going to put as a recipe, pretty much, pragma once here for this file, so that in case of multiple inclusion, it's going to be handled gracefully. Okay. So once again, remember that pragma once here, we could have used the old technique, which is if not define a symbol that has a name that is pretty much the name of the file with a bunch of underscore, then define the same symbol. Okay, I'm not going to re-explain because I already covered that in the previous video, but just show you how we would use it. Okay, we could encase everything in the header file like so in those guard statement, or we could use the more modern pragma once directive to the precompiler, and it's going to ensure that multiple inclusions are prevented for us automatically. Okay, so we have a few lines of code, which means we have potential for already making plenty of mistakes. So GCC, well, it compiles, it runs. Okay, we didn't break anything yet. Now let me grab this, and I'm going to go to hal.c. So hal.c, it's a command to include the header file into the corresponding C file so that you have all of your function for that file already declared so they can call one another without problem. And then we're going to provide here the implementation for, for both of those functions. Here we are. Okay, so which one do we start with? Well, let's start with int-array display. So int-array display, again, the role is to be able to display the content of an array. So this one should not be a problem because it's going to be exactly the same thing that we did in the lecture, in some of the examples in the lecture. We need a counter control loop, and we need to iterate over every element of the array and display them on the screen. So why don't you pause the video, even if you watch the video because you didn't know how to get started. We got started already in the exercise, so why don't you pause the video here for a few minutes and attempt to write this. And if you have questions and problem, office hours, forums, Piazza, whatever we're using this semester, and then unpause the video and I'll show you real quick a solution. So I'll show you a possible solution, but that doesn't mean that this is the only thing. If you came up with something different that works, actually, then no problem, kudos. You don't have to adopt the solution. I'm using a for loop, for example, for my solution, because I like to use for loops whenever I have to do counter-controlled looping. So I'm going to declare a variable inside the for loop. It's a small function, really it doesn't matter, but I like to do that every time I need an index or a counter variable to declare it inside the for loop, except if I need it outside the for loop, and in this case I don't. And what I'm going to do is I'm going to say for I equals 0, I lesser than, so the size is given to me here as parameter, I plus plus, the size of my array, and then inside this I'm going to display printf, and I'm going to display just a message here that says, for example, here's the value. Here's the nth value with a space after, so that we can see actually that we can see clearly the different values in the array. Okay. Where do I get this data? That might be useful for me to specify that. Data, the parameter, index I. And then after this, so I don't use a curly brace because I have only one statement really in my for loop. After this, I'm going to display a new line so that if I call multiple time int-array display on different arrays, I'm going to make sure that all of them are separated by actually a new line. This is arguable whether or not we should do that, okay? And then I'm going to add, just for aesthetic reason, okay, I'm going to add another printf here, and I'm going to say, you know what, when I'm about to display an array, I'm going to put a square, opening square bracket, then all the elements separated by space, and then I'm going to close the square bracket here at the end. Okay, so it's just so that when I see an array displayed by this function on the screen, I kind of get a cue that this is this function displaying an array. It's not just a sequence of numbers separated by space. It's going to be a sequence of number separated by space and encased in square brackets. Okay. All right. We have already something that we can try to compile just to get rid of all any pesky syntax error, and we have some stuff already missing here, like printf. Where is printf coming from? Well, find include stdio.h. There we go. Let's make the compiler happy. Go back here. In function int_array display, multiple definition of int_array display, blah blah. First define here. In function int_array scan, etc. Multiple definition. So it's telling us you have multiple definitions here of your function int_array display and int_array scan. Well, we have only one definition here, right? So we have not been duplicating our definition, but it's telling us that pretty much. Let's track down on the error here. In function int_array display is telling us that it's during linkage that we find that there is such a problem, and this is a source of the problem. This is where the function is first defined, the file hal.c. Well, yeah, this is exactly where I want it defined. So hold on a minute. What is happening here? We have prototypes. We have hal.c. Let's see. Okay, I'm going to have to play a little bit. I will be right back. All right, we're back. I had to play a little bit of Where's Waldo, and this is our culprit. A simple typo here where, for whatever reason, I was including hal.c here instead of hal.h. So this is actually an interesting example of what happens when you have multiple multiple inclusion in this case, but not even of header file, multiple inclusion of a source file. So we had actually in test.c the same code that we had in hal.c, hence the double definition. So when stuff like that happens, don't freak out, just take your time, okay, go over all of your code, verify your header file, your source file, and then everywhere and this is the last step that I took, and this was actually where the error was, everywhere that you include that library and use that library, verify that you did the inclusion correctly. So we're going to test it. Actually, I didn't test it yet, so let's go here, gcc test.c hal.c. Yes, it's working a lot better now. Out, still working. Okay, so watch out. Okay, don't do what Johnny don't does, whatever. I don't remember how this expression goes. But here, make sure that you always include a header file and not C files. Okay, pay attention. Not like what I did there. All right, going back here. So we have something here that we could start testing. So we're going to do it very simply. Okay, we're going to say int array underscore, and then we're going to call display, and I'm going to display something called my array. Why not? And I'm mixing like different case notation here. I should not do that. There we go. My array, and my array is going to be of size, let's say, I don't know, 10, and I'm going to define it right here. Okay, so int my array, and I'm going to initialize it with an initializer list here. So I'm going to say this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That should be 10 elements. There we go. And then I'm going to display that, and then that's it for my test. So this is what I referred to when I said some of the tests are not going to be automated. This is a function that displays something on the screen. So I should really probably play with it in the main.c and make it interactive, right? Because there's really nothing much to test here. You just call it and inspect visually, you know, whether or not this is the right array. So excess element in my initializer, yep, that's perfectly legit because I said it was an int, a single int being equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's kind of a lot for that single int. So let's compile here. Let's run. There we go. Running tests on hal functions 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. So now that we know how to display an array, what we are going to do next is we are going to do an int array scan with the same array variable. So I'm going to read the 10 element of that array, and then to make sure that I read them right, I'm going to call again int array display, because now I know that it works, okay, with my array size 10 and redisplay it on the screen. So again, not really automated testing here, right? We are going to visually inspect that whatever we entered is whatever we got. All right, so just to make things a little clearer, testing, displaying, well, actually, you know what? Testing int array display. Those methods have names. Let's use them. All right, and then here I'm going to say printf testing int array scan. All right, so that's going to make it a little easier to follow on our output. But right now, I don't have actually an int array scan, so I better get working on that. So int array scan is going to be pretty much built on the same pattern, right? That's why we get rid of those first. There's a very, very easy function, and they are all going to fit in this first video without being too long. So int array scan, same idea. I want to print out something like, for example, reading an array of int of size of, sorry, whatever, of the elements, okay? And I'm going to specify size here. So this is just like a little header. And then I'm going to enter a for loop for I equals 0, I lesser than size, which is given to me as parameter, I plus plus. And what I'm doing inside, I'm going to do printf. And just for aesthetic reason, I'm going to put a tabulation, okay? I'm going to put a tabulation and I'm going to say enter value at index %d I, %d, and then I'm going to put I here, all right? And I'm going to read that value. So I need to do more than one thing in my for loop, so I need those curly braces. And here I'm going to say enter the value, and then I'm going to say scanf. Scanf %d because I'm reading int value. So if you were redoing this exercise with double, you would use %lf. Ampersand data index I. There we go. So we have something that should be able to read all the elements, and we don't return anything from this function, but we modify what's inside the array data. Okay, that's how it works. I'm going to save that. Let's go and take care of compilation errors. No compilation error this time. Let's try to run it. So running test on HAL functions, testing int array display, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that doesn't change, it's still working. Testing int array scan, reading an array of int of 10 elements. Enter value at index 0. So yeah, I should probably I should probably use a new line there, but okay, let's roll with it for now. So what I'm going to say, I'm going to reverse that array that we had at the beginning. So I'm going to say I start with a 9. Value at index 1 is 8. Then 7, then 6, then 5, then 4, then 3, then 2, then 1, then finally 0. And it displays the array in reverse order, which is exactly what we wanted. So let me fix here things a little bit. This is too long. Reading int array of %d elements, size, and then we are going to put the backslash n here. There we go. And then everything should align perfectly. Let's double check that real quick. Yes, there we go. That's a lot better. There we go. And here we are. All right. Okay, so we have our basic testing in place. Okay, we have our implementation of the two first functions. We are going to wrap it up here for this video, and then the next video is going to keep working on this very exercise, and implement progressively all of the functions that we have in the requirement. As usual, thanks for your attention. If you have any questions, Piazza Forum, whatever we use this semester, or office hours, of course.